Welcome to the shop. I'm continuing NQALHA Production Run 5 while learning to use my new Haas Mini Mill 2. And little bit by little bit, every set of parts I make, I get a little more confident and make a little bit fewer mistakes. I'm not showing every single step in the process in this video series. I'm just going to show some highlights. Production Run 4 was far more completely documented, and a lot of it was repetitive and redundant. So this one I'm going to kind of like strip it down a little bit. In previous videos, I was kind of debating whether or not I should show my mistakes. But for somebody who's interested in just understanding, what does it take to learn a new machine and compute fairly complex tool paths for the first time, it might be informative just to watch the process, mistakes and all. But in the last couple of days, there really haven't been any mistakes. Things have been going very smoothly. Procedures are being practiced, strategies are being refined, and I'm just getting more comfortable overall. So today's part, I'm going to be making what I call a combo toolpath, where I have two different parts being machined, one on the right vise and one on the left vise. And the toolpath program doesn't know how to do that. So I had to create toolpath for the part on the right vise, create toolpath for the part on the left vise, and then kind of like intertwingle them together by hand. And of course, anytime you do things by hand, there's always a chance for making a mistake. And so I've developed a procedure that involves putting comments, modifying the post processor for BobCAD to put in appropriate comments that guide me along the way instead of just trying to figure out big ass blocks of G-code. I can follow the comments and see what's going on, and this helps me avoid errors when I'm intertwingling the right side and left side parts. So I've already run a few parts and I know the toolpath is going to work. So let's just run one. So in the first video, I talked about skinning the top surface of the part for dimensional consistency as well as surface finish, and kind of speculated on, I don't know, should I skin them all? And I decided, no, I'm not going to skin them all. I'm only going to skin them when I need to. Because, hey, why bother? The surface of the material from the mill is good enough, and if I've got a scratch in it, I can Scotch braid it out. But in this part, I'm skinning to hold dimensional tolerance, because in Production Run 4, I put a piece of material in the tarmac and measured the position of the top surface, and then proceeded to reference from the top surface down, thinking that, well, okay, that's going to give me an accurate depth, because the slot that I'm making for the clamp bar, I wanted that to be fairly well controlled. Well, it turns out that that was a stupid thing to do, because taking a measurement once from the top of a piece of stock and then running a whole run with different pieces from the same extrusion, yeah, they're probably close, but I shouldn't count on the stock being uniform size. That's just sloppy. So for this run, I'm skinning the top of the part that I care about controlling the depth of the slot. I'm skinning the top, and then with the part in the same vise, in the same operation, cutting the slot with an end mill, and by doing this, I can hold the depth of that slot to a much greater tolerance. So let's run the combo toolpath here, full speed. Make sure that I don't have anything going on here. I'm going to be running at full speed. Love that 3-inch insert face mill. Just does a beautiful job. The inserts that I'm using are optimized for aluminum. Now I'm going to be drilling some 1/2-inch holes, and when I first set up this part, I was somewhat concerned that I was getting buildup on the drill bit, this horrible rat nest, and I thought, oh, I solved that a long time ago. What's going on here? Well, it turns out that for one reason or another, I don't know how it happened, the drill bit kind of got damaged a little bit. And so here I am wasting a bunch of time dicking around with feeds and speeds and try this, try that, try this, try that. And I didn't check the drill bit to see, well, are the flutes in good condition? And it turns out that under the microscope, a tiny, tiny little nick on one of the flutes resulted in generating a rat nest. So now I'm cutting a slot with a 1/4-inch end mill running at 10,000 RPM, and gotta do it slow. Even at 10,000 RPM, you can't go too fast with a 1/4-inch cutter. So to avoid a tool change, now I'm going over to the other side, and I left in, when I was intertwingling, I left in the spindle stop and spindle start because it doesn't take any time, and I certainly don't want the spindle running when I try to do a tool change. There's too many chances to make a mistake, so I think I'll just leave in the spindle stop and spindle start, and that way the only thing that I have to do by hand is the work offset is modal, and so in the first program it assumes G54 throughout. So whenever I intertwingle, I have to manually insert a work offset. But if the only thing I manually insert is the work offset, that's a fairly low chance of error if I get it wrong. So it's going to be drilling some holes. I'm using the 10,000 RPM spindle a lot, especially for end mills and small diameter drills, and it works really well for me. But like I said before, the last two parts have been very smooth. I have a procedure in place where I convert from the old design for the Tormach, and I've got a sheet with the set of steps that I need to either perform or check. And so far, if I follow my checklist and follow my procedure, there's no errors, and the conversion goes very well. I discovered a new feature in BobCAD called Array of Parts, and I'm going to be using that in the future. When I did what I call a gang of parts before, I actually, by a gang I mean a small part on the left and another identical small part on the right. Let me get my finger over here. A small part on the left and a small part on the right of the vice jaws. And this does two things. It equalizes the clamping pressure because the vise doesn't really like holding a small part on one side. And it also doubles my production. And in the past, I did this with just making a CAD drawing of the two parts in the vise. But now that BobCAD can do an array with two different work offsets, hopefully it will work a little better and I'll have a little better luck. So I'm going to show that probably in the next video I do. So this ends the first operation on the first two parts, which are the clamp body and the clamp cover. The next operation is going to be to screw them together, put them on a tooling plate, and mill the perimeter. Then they get flipped 90 degrees, and the sharp corners of the slot for the back bracket get cut out, and holes get popped in and tapped. So that's all for the first operation. I'm going to run the batch, turn the camera off, and come back a little later. So see you later. The first operation has been completed for the clamp body and the clamp cover. Since they're very similar to each other, I had the clamp body in the right vise and the clamp cover in the left vise, and that kind of minimized the number of tool changes and got fairly good production going. So now I'm doing a bit of a special operation. This is the only part where I do this. Since the parts are a matched pair, I take the body and the cover and put them together onto a special tooling plate. So I made two new tooling plates because the old one was kind of beat up, and I'm doing two at the same time here to increase production. Now, usually when I talk about Bobcat, I complain about Bobcat because, you know, there's a lot to complain about. But I'm going to interrupt my complaining for a moment and say, hey, wow, I just discovered a new feature in Bobcat. Works really good, where I can set up an array where I do a toolpath in one work offset and then go to a configuration page, duplicate that entire toolpath at a different work offset. So now I have my work offset 1 and work offset 3 tooling plates are as identical as I can make them, and I can run two sets of parts at one time and minimize tool changes and get the production up. So I'm going to go over to, I'll put on the safety glasses, and there's possibly a tiny bit of a burr on the top of the mating surface. So this is a slightly interesting tooling plate where I have two steel pins fairly accurately made, and they're like 1/1000th or so loose, so I can slide the part on without pressing, but they're still close enough that they align everything correctly. And then I use the 1/2" socket screws with aluminum washers. Since this is only a tooling plate, well, actually, why did I say that? This is a part, I gotta keep it careful. So, got my two stacks of parts in place, going to be using the high-speed machining operation, and let's get this pig doink. 250 inches per minute, the Lakeshore Carbide 1/2" 3-flute zirconium nitride coated solid carbide end mill designed for aluminum use. And yes, I did properly program my retract to keep it away from that big ass screw. So the array function works very nicely. And it's just going so fast. On the Tormach, I did it with multiple passes using a 3/8 roughing cutter to kind of cut a slot And with this guy, I just turn it all into chips, HSM, do a finish pass, and that's a real mystery. Why did it stop there? There's nothing in the G code to tell it to stop. So, I don't know, is there a bug in the control? This is pretty weird. Yeah, and then it's, yeah. If it ain't one thing, it's another. So there we have two sets of parts. Totally beautiful surface finish. I got one more operation to do on this set of parts, and that is that the inside corner here is rounded, so it needs to be square, and I gotta drill and tap some mounting holes here, so it gets one more operation, and then these guys will be finished. So it comes off fairly easily, but not perfectly easily, especially when my hands are slick with coolant. It is kind of almost like a lubricant. So I'm going to run the rest of the parts and then set up. I made a new set of tall soft jaws, and going to be using the new soft jaws, tall soft jaws, to position the part in place when I do the next operation. So I'm going to turn the camera off and come back later. The first and second operations have been performed successfully, and now it's time to do a somewhat non-standard operation. This is the only combination of parts that I do this with, and it just seems to make sense, where I screw the two parts together in the orientation that they'll be used, do this on the tooling plate with pins to make sure it's aligned correctly, and then cut both parts at the same time. Remember that, let me get over on the GoPro here, the inside corner cut in the previous operation needs to be sharp, and so when I turn this assembly perpendicular, I can cut it with an end mill. So I'm over here with the electric unscrewifier, using a very light torque so it doesn't jerk the part out of my hand, and assembling the stack. So now I've got two stacks ready to go, and I switched out the soft jaws to jaws that don't have a ledge on them to get a little more clamping surface. The part will be referenced at the vise surface, and this will be work offset 2 and work offset 4. I don't have a work offset for every combination of coordinates that I commonly use. That would be just too many work offsets. So I try to keep it somewhat sensible and somewhat minimal. So work offset 2 is always referenced to the vise surface. Work offset 1 is always referenced to the rear left corner, but the Z can be either the bottom of the part, the top of the part, top of the tooling plate, so it's got a variable Z. I'm also using the Bobcat array function that I just learned how to use, and it seems to be working really well. I've already tested this one, so I don't believe that I need to test it again, so I'm just going to run it at full speed. Hey, been tested. There was a little bit of a chip on the tap. The rigid tapping on the mini mill so far has been completely without problems. Mostly the chips just, I'm using a spiral fluted tap, and mostly the chips just eject out the top very nicely and get washed away by the coolant. Occasionally a chip will kind of get wrapped around the tap, but it hasn't gotten caught yet. It hasn't broken a tap yet. They just eject themselves out. So far so good. Rigid tapping is working very, very well. So I'll go ahead and run this pig. Half-inch end mill. That was 90 inches per minute. With this machine's rigidity and power, I don't have to turn the feeds and speeds down like I did on the Tormach, where I had to be oh so careful about tool pull-out and chatter, and I never really overloaded the spindle. I did have a spindle power meter, and it was sometimes getting into the yellow zone, but mostly the limitations on that machine were other things. Really not much going on this operation. It's really fast. My cycle times on this machine are so fast that sometimes I don't have enough time to do all the stuff that I do while I'm normally waiting for the machine to finish. Cutting a blank, deburring a blank, deburring the previous part, and so sometimes the machine is faster than I am. So, hey, there we go. So that concludes the clamp, body, and cover machining operations. Next thing, they go in the vibratory polisher, which I'm not going to show because it's not that interesting, and I think I tried showing it once before, and it's so noisy you can't really hear anything, and got to move the camera outside, and it's getting dark. And anyway, that's all for today's video, so see you later. It's been fun, and continuing to get more fun as I master this magnificent machine.